In this video, we'll be talking about the graph of the cotangent function. As you can see, I've done an XY chart and plotted the points for the values of cotangent x. My x values are in degrees. I did that because students are usually more familiar with degrees than they are radians. And our radian measures then for negative 180 would be a negative pi, and then for negative 90 is negative pi over 2, and this is 0, and then for 90 is pi over 2, and for 180 we have pi, and then for 270 is 3 pi over 2. So these are our main values that we'll need to be familiar with the radians. Some things that you'll notice about the cotangent curve. Here is my y-axis, and on my y-axis I have the guidelines for an asymptote. So my cotangent curve increases to infinity as I get closer and closer to the x value of 0. So I have an asymptote at 0, and then my next asymptote is at pi. So the period of the cotangent function is pi radians, or 180 degrees. Push this up a little. So I have asymptotes at negative pi, and then 0, and then pi, and then my next one would be 2 pi, and so on. It's a periodic function, so it continues this pattern. So my asymptotes occur at pi, where n is an element of the set of integers. So this is where my asymptotes occur. Also, I have zeros where the cotangent function crosses the x-axis. I have zeros at negative pi over 2, and then pi over 2, and 3 pi over 2. So my zeros occur at odd multiples of pi over 2. So we can write that algebraically by asking ourselves what stays the same and what changes. So I see that I have pi over 2 in all of my values. And then the coefficients, negative 1 with positive 1, 3, so forth. So I show an odd number by taking 2n, which is guaranteed to be even, and adding 1 to that. So 2n plus 1, that quantity, times pi over 2, where n is an element of the set of integers. This is my zeros. Also, if we were looking at accuracy on the graph, notice at 45 degrees, my cotangent is 1. So 45 degrees away from the 0 on either side, you'll have a positive 1 or a negative 1. Those values will help you with your accuracy of your graph. So if I were going to just sketch my cotangent, I know that I have an asymptote at the y-axis, and then I have another one at pi, and I have another one at negative pi, and then halfway between the two asymptotes, this is at pi over 2, I have a 0, and at negative pi over 2 I have a 0. And then to help with the accuracy, remember that from 0 to pi over 2, that represents my first quadrant. And all of my trig functions are positive in the first quadrant. So at 45 degrees, I have a cotangent that's equal to 1. So plot the 1 there, and then in the next quadrant, I have a cotangent which is negative 1. So my cotangent curve looks like this. And then since my function is periodic, just repeat this curve. For as many periods as you need. Let's look at some important information about the cotangent function. The domain is the set of all x such that x is not equal to n times pi, where n is an element of the set of integers. This represents, since x is not equal to this value, that's your x values where the asymptotes occur. The range is all real numbers, so up and down we have no restrictions on the range. It's discontinuous at x equal n pi, so these are our vertical asymptotes. The x-intercepts, or the zeros of the function, occur at x equal to quantity 2n plus 1 times pi over 2. So these zeros occur halfway between my asymptotes. The period is pi. We have no amplitude. The coefficient of the cotangent function represents a stretch or a shrink of the curve. And it's symmetric with respect to the origin. Therefore, it's an odd function. That means that the cotangent of negative x is equal to a negative cotangent of x.